Day 12. How matching engines work. The matching engine is the heart of every electronic exchange. It receives orders, matches buyers with sellers, updates the order book, executes trades, and publishes new market data back to the market. Every electronic exchange has one component responsible for turning orders into trades, the matching engine. Whether the market is stocks, futures, options, ETFs, or cryptocurrencies, every submitted order eventually reaches this system. Its job sounds simple: receive orders, match buyers with sellers, and update the market. But at modern scale, it is one of the most performance-critical systems ever built. A matching engine is the core software component of an electronic exchange. It continuously receives new orders, cancel orders, and modify orders, then determines whether a trade should occur. Whenever a compatible buy and sell order exists, the engine executes the trade automatically. There are no human traders approving transactions. The matching process starts with the order book. Suppose the best ask is 101.10 with size 10. A trader submits a buy order for 10 at 101.10. The matching engine compares the incoming buy against the best available sell order, executes the trade, and updates the remaining book. This usually completes in microseconds. Matching engines support several order types. A market order executes immediately and consumes the best available liquidity. A limit order executes only if the specified price is available, otherwise it rests in the book. A cancel order removes an existing order. A modify order changes price or quantity, and many exchanges internally treat that as cancel plus new order. Most electronic exchanges follow price-time priority. Higher bid prices execute first. Lower ask prices execute first. If multiple orders exist at the same price, the earliest submitted order executes first. If Trader A and Trader B bid the same price, but Trader A arrived first, Trader A receives priority. This creates fairness and deterministic execution. Not every order executes completely. If the book contains a sell order for 5 at 101, and a trader submits a buy order for 10 at 101, only 5 can execute immediately. The remaining quantity is 5. Depending on the order type, it may rest in the order book or continue matching against additional price levels. A simplified exchange architecture starts with the client, then the gateway, then risk checks, then the matching engine. If a trade occurs, the exchange publishes market data back to participants. Every successful trade becomes new information. This feedback loop runs continuously throughout the trading day. Matching engines must be fast because exchanges may process millions of orders per second. The engine must validate orders, maintain the order book, match buyers and sellers, generate trades, and publish market data without adding unnecessary latency. This is why implementations often use C++, Rust, or carefully tuned low-latency Java, with attention to CPU cache, memory allocation, lock-free structures, and network I/O. Many beginners assume the fastest matching engine is always the best. Professional exchanges care even more about correctness, fairness, and deterministic execution. An engine that sometimes pauses for 10 milliseconds is more dangerous than one that consistently responds in 50 microseconds. Consistency builds trust, and determinism builds reliable markets. A matching engine and a trading engine are different systems. The matching engine belongs to the exchange, and its job is to match orders. The trading engine belongs to the trader. It receives market data, generates signals, manages positions, and sends orders. The trading engine never decides how orders are matched. That responsibility belongs to the exchange. Godzilla.dev is not an exchange, but many of its architectural principles are inspired by exchange design. Professional trading systems need high-performance market data processing, local order books, deterministic event handling, risk management, and ultra-low latency order routing. These components continuously interact with external matching engines. The key takeaway is that the matching engine is the heart of every electronic exchange. It receives orders, maintains the order book, matches buyers and sellers, executes trades, and publishes market data. Modern markets depend on highly optimized matching engines, and understanding them is essential for building professional quantitative trading systems. Next, we move from exchange internals to connectivity. The following chapter explains exchange gateways, the systems that allow trading engines to communicate with exchanges, send orders, receive responses, and operate reliably at low latency. Subscribe and keep building the AI Quant Trader Foundation with godzilla.dev.